I think we can start our presentation as few members have already joined. So welcome everyone for this journal meeting. Can you guys see my screen and the voice is clear? Can you confirm one more time?
Yes.
Okay, thank you. So my today's paper is the title of the paper is Enhanced Bitcoin Price Direction Forecasting with Deep Q Network. So this is the very recent paper published in February 2024 and published in IEEE Access. This is the link. If you want to access, you can do it. So the main motivation of selecting this paper is you all know that I have also a plan to work on the cryptocurrency price trend prediction model. So I found this research work is very similar to my research. So I select this paper as maybe it will be one of the baseline paper to start my research. So that's the reason I select this paper as to present in the journal club meeting. So these are the content of today's presentation. First, I will try to explain the abstract of this paper, and then I will describe the key contribution of this paper and the remaining part of the data preparation, the techniques they use. One is Pearson and another is a deep Q network. And then I will show the evaluation result, discuss the conclusion and the limitation of the paper. So this is the abstract of this paper. Actually, I can segregate it into the four parts. One is the key influence factor, they figure out what are the influential factors that has a relation with Bitcoin price. So initially they select 14 data features as related to the price. They include the historical price, trading volume, network matrices, social indicator like Twitter sentiment or the Google search trend. In the second contribution part, they actually utilize the deep Q network. That is one of the latest technique they have been used in this field, and they also introduced their innovative reward function that I will describe in the later section. In the third part, the reward function is this is a multifunctional reward function. They consider the prediction accuracy, confidence scaling, penalties score for a recursive error, or the time-based discount factor for their reward function. And finally, they showed that their model perform F1 score around 95. That is one of the benchmark score so far. So in their paper, they mentioned the three contribution part. One is they design a multimodal data set. Multimodal data set is like they collect the price information data like Bitcoin daily hourly price and their trading volume. They also collect the on-chain network matrices like blockchain network information. They also include the social influential factors like Twitter or Google trend, and based on that, they generate a full 14 features multimodal dataset. They also introduced the Pearson correlation method to select the best features, and finally they use their own algorithm that perform better than any other model so far. So how here I will describe how they prepared the data set. Initially, they took the range between 2014 to 2018 data, and they collect the hourly data set. And for the hourly base, this 4 years data has total over 40,000 data point. So initially, they took the crypto compare API, use the crypto compare API and blockchain API to extract the price information and the blockchain on-chain record. They also utilize the two other website like CoinGecko and CoinMarketCap, and for on-chain record, the blockchain.com Explorer, because they say that if they only depend on only one data source, maybe the data will be inconsistent. So they just cross-verified with the other source that their data is clean and have the consistency. For on-chain record, they actually include the hash rate, transaction count, average transaction volume, active address, inflow and outerflow exchange, and so on. So they actually focused on Bitcoin core network information. And similarly, they collect the 7 million Bitcoin related tweet from Twitter using the Twitter API. They usually use the hashtag Bitcoin and BTC to collect this tweet, and they use Wahidur to analyze the sentiment of the dataset. And they also used the Google Trend and Twitter Trend matrices and incorporate that information also in this dataset. When they collect the on-chain data, they did the pre-processing, like they handle the missing values, they reduce the noise, they do the feature scaling, they also did the temporal alignment, and finally they did the feature engineering that are very prerequisite for doing data analysis task. If you see the summaries, in the summary, you can see that they collect the three modality data, one for price and trading volume information. Another is blockchain core information, and from there they collect the most of the features. And another is social interaction data, is Twitter sentiment, Google trend, and Twitter trend in the data set. And the data is collected from 2014 to 2018. They used Pearson correlation to figure out the which features are most important for their analysis. So let's describe what is Pearson correlation is. Pearson correlation is a statistical tool that can give us the understanding about the relation between two features. Like you can see the positive correlation, negative correlation, and no correlation. The positive correlation is like we have two features, X and Y. If X is increased and the corresponding Y is also increased, and they are following the trend, continuous trend, that we can say this is the positive correlation. Is alternatively, if the X has increased, then the Y will decrease, that is the negative correlation. And finally, if there is no relation between, then this statistical model will give us that there is no correlation based on the value. So actually they use this formula. One is xi is the value of the features, and x is the mean value of that particular features, and the range is between -1 to 1. In here, they actually initially collect the 14 features from the three modalities, and they check the Pearson correlation, that which features are highly correlated with their price information. And finally, this table shows us that few features like hash rate, the average transaction values, like this one, exchange inflow, that got very poor number, like 0.5 and to less than towards -1. So they select these values have no relation with the price information. So finally, they eliminate these features from their features table and got only 7 final features to feed into the model. They used DeepQ network. Actually, I have less idea about how this Q network work, but initially the idea what I get that this is actually based on the Q table learning strategy. Initially, Q learning strategy is like agent have a state, and from that state, it will take the action. Based on that action, it will get the reward. So in normal traditional Q learning table, it has the 4 state or 6 state like a normal agent is doing. But when it come in the deep learning network, the state is not fully designed for that statistical model. That is now you can see the equation here. The Q value is designed based on the Bellman equation, and it also related with it state and the action. And the alpha is the learning rate and the reward, and gamma is the discount factor. So it's in traditional Q learning and deep Q learning, I found only the differences in the approximation cases. They include the weight of the model, but initially in traditional Q learning, there is no weight input as a approximation state. Other values are almost same. So they use this kind of deep Q network. Their input is 7, like because initially they select 14 features. After doing the Pearson correlation, they eliminate the features that are not highly correlated with price information. So they found 7 features are highly correlated with the price. Then so the input features is 7 and the output is 3, because we have 3 decision. One is the price will goes up or down, or it will be no change. So based on that state, the output is 3. They use hidden layer 14, 7, 14, and these are the other values they use for train their model. They use Adam optimizer and ReLU active function. So in this scenario, what is state? State is like the initial features they feed into the model. So they found that important features, 7 important features. So that are the state of this Q network. So the state actually organized as matrices, and as it is, they are taking the hourly data. So the state is changing based on the hourly information they get from their initial database. And the action space is, I have already mentioned before, the action space is that based on the input data, what would be the final decision? So decision will be 3. So they will take 3 action. Either it will be increase, decrease, or there will be no change. So that's why the action space is 3. This is their own reward function. They are contributing here, like predictive accuracy increment. In here, if the model give us the accurate answer, then they will get a positive reward. If the model give us the error response, then it will get the negative response. The confidence adjustment scaling is like if the model give us a response that is correct, but it also depend on the confidence score. Like if the model give us the correct output and giving the confidence, high confidence, then it will get reward. But if the model give us the correct answer, but the confidence is low, then in such case, they also get the reward, but the reward weight is less than the previous one. And the reward weight is, we can tuning the reward weight using this reward function gamma. And consecutive error penalty is like if the model is giving the incorrect answer consecutively, then the model will get more penalty rather than the doing the normal penalty, and that factor is maintained by the alpha value. And time-based discount, this is very important for this Bitcoin or cryptocurrency cases, because this market is highly volatile. So this time-based discount factor actually giving the model a sense about that we should consider the recent data rather than the old data. So whenever the market strategy change, so that the model can adopt the changes rapidly. That's why they are giving this discount factor. So if they didn't give this discount factor, then the model will not consider the rapid shipment of the market. This is their evaluation scenario, how they said their model is performing better. You can see the F1 score is no change increase and decrease cases, all above 90% or even 92%. And they also compared their records with few others experiment that has done before. So in all cases, their model performing better is like 95%. Previously, it was highest score was 90%. And it was used only Q learning based model, but they used deep Q learning based model. And in the conclusion, that has mentioned before that they utilize features from multi-sources. They made a multimodal data set. They utilize Pearson correlation to evaluate the highly coefficient features. They utilize deep Q network algorithm and their own reward function to train the model, and their model achieved 95% accuracy. That is so far the highest score they have shown. But in the limitation section, they also mentioned that they only considered the limited features related to the price, because Bitcoin price has so many features. I mean, there are so many features that can affect the Bitcoin price, but in their research, they only consider initially 14 features, and after doing the Pearson correlation, they also reduced the half of the features, only feed 7 features to calculate this, to train this model. So this is one of their limitation. And in their future work, they are saying that they want to utilize the more sophisticated algorithm in near future rather than the deep Q network. So maybe it would be one of the transformer based function, or the combination of transformer based model or some other traditional model. So this would be their future direction. So actually, that's the end. But before ending, I want to say that this here They used the same strategy what I have planned to do, but on top of that, here we have some room to develop some work. Like they use traditional model to extract the sentiment. So we have used the transformer based model, especially the LLMs, to extract the sentiment, and we observed that traditional LLM based model perform better than the traditional model. So here we can improve one case, and another scenario is this is the Pearson correlation. They used only 14 matrices. In our case, we can utilize more features and utilize some other special kind of algorithms to select the best features. And finally, in the deep Q network, instead of this Q network, we can utilize the transformer-based architecture to predict the future. So from the paper, we have figured out their contribution and also the limitation, and from that I just got an insight that how I can develop my research to enhance the performance of such kind of algorithm. So that's the end from my side. Now, if you have any queries or suggestion, the room is open for you.
Can I guess? 안 들려요.
Yeah, your speaker is off.
So what is the different change from the original? It is just the same?
The network they used is same as before. They actually changed their reward function. So they include the reward function here. Actually, in initial reward model, we can consider that if the model give us the accurate answer, then it will get the positive reward. If they give us the error, then it will get the negative reward. But they can adjust few parameters like the confidence score. Like if the answer is correct, but the model is not that much confident. So if the confidence score is low, but the predictive output is correct, then they will get less reward. Instead of the confidence score is high and the result is true, then they will get additional extra reward. That's a bonus reward. And the consecutive error also, if the model consecutively give the wrong answer, then it will get more penalty. And this time discount factor, like as the cryptocurrency market is very volatile and it changes rapidly, so they add discount factor so that the model will consider put more importance on the recent data rather than the old data. So that's the changes they have made in this paper.
Thank you, I understand.
Thank you. Is there any other queries or suggestion? Okay, then I'm going to stop my presentation here. Thanks for listening.
Okay, finish today's journal club and thank you for attending.